Okay, guys, are you all there?
Yeah.
Yeah.
Right. Let me see if I can get the window. Okay, so we're doing the very brief RASMOL demonstration now. So you've gone into Moodle and you've downloaded the RASMOL folder, so the zip file, and then you created a folder on your laptops called RASMOL. You've all done that. Yeah.
Right.
Good. So let's see if I can share my screen with the RASMOL stuff on. So if I go to that. Right, so I've downloaded. Can you all see that?
Yeah.
Okay, so I've created a folder called RASMOL onto my laptop, and I've transferred the zip files from the Moodle into this folder, and then you just click RASWin. So if you click RASWin, just type OK there. So just go to File. You need to open a file in this folder. And since we've just seen the Lysozyme video with Sir David Phillips, we'll click on that. PDB, anyone knows what PDB stands for?
No, not really. No.
It stands for Protein Data Bank. So it's where protein crystallographers deposit the protein structures once they've evaluated them, and also NMR scientists for smaller proteins which can be solved with NMR. But generally, crystallographic structures are deposited on the protein data bank. So all these files here have been downloaded from the protein data bank, and there are very, very many more, but these are just ones that we've downloaded for you. But you can download others. Notice the albumins here as well, and hemoglobin, or deoxy and oxyhemoglobin. Let's just click on Lysozyme and open that, and you can see
Yeah, I've got it here.
Okay, this is a wireframe model for.
But I actually can't see it on my computer.
Can you see it? Okay.
Let me try again.
Don't use yours for the moment. Just don't try and copy. Just view what I'm doing now. Then you can do what you're doing later. So we've got the Lysozyme coordinates into the RASMOL program, and there's display. First of all, can you see me now?
Yeah.
Showing the options here for display wireframe.
Yeah.
backbone, sticks, space fill, picosecond time interval. That's what we saw in the David Phillips interview. So ellipsoidal shape. Ribbons, strands. Okay, so this is sort of monochrome. This is not so exciting, but we can go to colors and okay, there's only one chain because it's a monomeric molecule, lysozyme, and that's the chain, but group is good. Or structure, because this picks out the secondary structure in the molecule. It's the beta down here, but the yellow, okay, represents the beta pleated beta sheet, okay, or sheets, and then the pink color are the alpha helices. And there's a sort of long one here, seen end on. So you can just rotate it to pick out different aspects of the structure. Go back to display again. And we can, so colors, yeah, group, let's go display ribbons. Okay, so it's your choice really, but again, people vary in terms of which they prefer or what they're trying to show, space fill, wireframe, ribbons, or strands. Strands seem to be quite popular at the moment, or you can go back to wireframe again. This is similar to what David Phillips was showing in his video, and you can even, I'm not sure whether you can hear this on your, I'll play this, but you probably can't, I don't know if you can hear it or not. You hear this?
No.
Nah. I think I can play it on my side.
Did that come through? It doesn't always come through on Teams. Could you hear that music?
No, it's not.
No.
All right. Let's see if I can create that, because sometimes you can't hear what comes out on my microphone. You can just hear. I'll just see if I can play that from here. Let's go. Bear with me 1 second, folks. Yeah, that's on it. Gosh. We're going to get there in a second, folks. Don't worry. Let's see if we can pick it up on here. Right, let's play that. Okay. Okay, that's a very poor attempt to try to reproduce what
what's
was
the
on
music for?
the David Phillips video when he was playing Mike Oldfield's Tubular Bells. He was rotating the molecule. But I've got that file on here for you anyway, which you can play. I'm sure if you click that, you'll get that music that we had. Not that that's critical. So you can a whole array of things you can do with this, and I've given also some other examples of molecules that you can load up. So open. There's ovalbumin, and you notice I've got ovalbumin uploaded at the same time as the lysozyme molecule, so you can compare the sizes and different groups of different molecules by uploading more than one into the RASMOL frame. Let's just reload that again. RASWin. Okay. File. Open. Ovalbumin. Okay, there we are. You can see the sort of two domain structure of the ovalbumin molecule. See one colored in blue and the other in green. They're covalently linked, so it's not like hemoglobin. Let's close that and open hemoglobin, oxyhemoglobin. Colors. Chain. Okay, got the alpha and beta chains of hemoglobin. Let's see 4 of them. Okay, so when you come to do the assay, those wonderful alpha helices, but when you come to do the assay on hemoglobin, we haven't got sickle cell hemoglobin on here, but you can get that from the Firth and Moore reference, which I've given you online. You can take snapshots of the various aspects of the structure that you want to show to illustrate a particular point. In this case, it's the alpha helices in the molecule. So it'd be nice if you could show some of your own created images. Obviously, if you use RASMOL, you need to acknowledge the fact that you've used RASMOL for that. But yeah, you can spend some time just going through these molecules which I've given you. They're not. Oh, it should be. Yeah, there's a transfer RNA here as well. Let's just close file, open. All right, that could be useful for when we talk about nucleic acids, I think next time. I'll twist it round. Okay, you can have quite a bit of fun here playing with this. Better on for expand it out. That's better. Let's go display. That's with strands, ribbons, space fill. Yeah, so you can just experiment with the display which you have and the colors. Okay, so that's something for you to do in your own time. Let's go back to Teams console again. Console and stop sharing. All right, so that should keep you busy for quite some time. So what I suggest you do is just to, in your own time, just to rerun through the stuff that we've just been covering, and don't forget how the macromolecular folding assembly is, how it's dictated by the free energy equation and the second law of thermodynamics, delta G equals delta H minus T delta S, and the delicate relation between the delta H and minus T delta S terms. So for a macromolecule to fold or to self-assemble into an ordered structure, delta G has to be
Negative.
Negative.
Okay, so if it's negative, it'll happen. If it's not negative, it won't happen. And you know, with proteins, it all depends on the sequence of the amino acids and the environment that that sequence finds itself in. That basically summarizes what we've been doing over the last 2.5 hours or so. So any questions on that, folks?
When will the assay due?
Sorry?
When will be the deadline of this assay?
All right, so if on the Moodle that you should find the details of the deadline submission. It should even be on the timetable. Let's just see if I can. Let's just stop recording. So let's just stop recording.